Bright Tuty. Every student matters.
Hello students, let's start the chapter Exponents and Powers. So, I know that you're already familiar with the topic as you have already done it. So, what are exponents used to? Suppose I write a to the power x. This is known as the base, right? This is known as the exponent. It can be positive, negative, 0. Okay, exponent can be any of the positive number, the negative number, right? Now, this complete is known as a to the power x. What is the power of a? It is x. Okay, now how or where they are used? You know, the standard form of exponents we will learn, and in that we will actually get to know about the uses or the applications of exponents. What we do in that is we express them in the standard form, and very large and very small numbers can be easily expressed. Like suppose I have to tell the mass of earth, mass of moon, right? That's a very large number, so we can express them easily using standard form of exponents. Also, to write the results in simpler form, exponents are used. Okay, so if you see here, I'll be telling now powers with negative exponents. Suppose I say 2 to the power minus 3. So this is a negative exponent. What is this? This is a negative exponent. Right? So in this chapter, we will mainly focus on negative powers. What we are going to focus on? Negative powers, right? Powers with negative, this is complete power, right? So it is with a negative exponent now. So 2 to the power minus 3 is written as 1 upon 2 to the power 3, right? This is the law that we have used. A to the power minus 1 is 1 upon a. So similarly, 2 to the power minus 3 is 1 upon 2 to the power 3. Now it becomes 1 upon 8, right? Or suppose I have 1 upon 9, that can be written as 1 upon 3 to the power 2, and we can write it as with negative exponent like this. Clear? So this is how we will be solving negative exponents. Now, if you see here, there are questions given. We have to find the multiplicative inverse. What is this term? Multiplicative inverse means reciprocal of that. Okay, suppose I say there is a number minus 3. Okay, what will be the multiplicative inverse of it? The multiplicative inverse of it will be minus 1 upon 3, the reciprocal of it. Okay, or suppose I have 3 to the power 2, the multiplicative inverse of this will be 1 upon 3 to the power, is the power that we are going to write? We will write it as negative. Okay, now let us try the question. The first one is 2 to the power minus 4. The multiplicative inverse is 1 upon 2 to the power 4. So, the result is if a to the power m is minus m is there, 1 upon a to the power m, this is known as its multiplicative inverse. Now, in the second one is 10 to the power minus 5, we will write 10 to the power minus 5 will be equal to 1 upon 10 to the power 5. So this is the multiplicative inverse of it. In the third one, we have 7 to the power minus 2, that will be 1 upon 7 to the power 2. In the fourth part, we have 5 to the power minus 3. It will be 1 upon 5 to the power. Make the power positive. 5 to the power 3. Okay. Then what do we have? The last part. We have the last part as 10 to the power minus 100. Right. So how do we write that? In the fifth part, 10 to the power minus 100 will be written as 1 upon 10 to the power 100. These are the multiplicative inverses. Okay, so we can express them in this way. Make the power, the positive power, the negative one, or the negative one as positive one. Okay, now moving on to the next. Here they are asking we have to express this in expanded form. Suppose I have 329. How do we write it in expanded form? We have already done in the previous grade. Okay, ones, tens, 100. 3 is at 100 place, multiply by 100. 2 is at tens place, 9 is at ones place. This is the expanded form we write. Now what about the numbers or the digits that are after the decimal? So this is 10th place. 10th place means 1 upon 10. 100th place means 1 upon 100. So we will write 1425.36. So this is ones, tens, hundreds, thousands. This is 10th and this is 100th. So we will write it as 1 into 1000 multiply with the place value, 4 multiplied with 100 plus 2 multiplied with 10 plus 5 multiplied with 1 plus 3 is at 10th place, 3 multiplied with 1 upon 10 plus 6 multiplied with 1 upon 100. Also this can be written as 10 to the power 3 plus 4 into 10 to the power 2 plus 2 into 10 to the power 1 plus 5 into 1, or we can write 10 to the power 0 because we know anything raised to the power 0 is 1. Then plus 3 into, here it will be 10 to the power 1, it will go into the numerator, it will become 10 to the power minus 1 plus 6 into, it is 1 upon 10 to the power 2, in the numerator it will be 10 to the power minus 2. So this is the expanded form of 1425.36. Moving ahead, we have to write them in the expanded form using exponents. So the first part, 1 is at which place? 1025.63. Ones, tens, hundreds, thousand. This is 10th place. This is 100th place. So 1 into 1000 is 10 to the power 3 plus 0 into 10 to the power 2 plus 2 into 10 to the power 1 plus 5 into, we will write 1, instead of 1 we can write 10 to the power 0 because 10 to the power 0 is 1 plus 6 into 1 upon 10. 1 upon 10 can be written as 10 to the power minus 1 plus 3 into 1 upon 100. 1 upon 100 can be written as 10 to the power minus 2. In the second part, we have 1256.249. 1 is at thousands place, 10 to the power 3. 2 is at hundreds place, 10 to the power 2. 5 is at tens place, 10 to the power 1. 6 is at ones place, 10 to the power 0. Plus 2 is at 10th place, that means 1 upon 10, which is 10 to the power minus 1. Plus the next is 4. 4 is at 100th place, so 10 to the power minus 2. Plus 9 is at 1000th place. So 4 into 10 to the power this is 9 into 10 to the power minus 3. So this is how we are going to express the numbers using exponents in the expanded form. Okay, moving ahead. Laws of exponents. So we already have done laws of exponents. Let us just recapitulate what we have already done in our previous classes. So we know if we have two numbers whose bases are same and the powers are different and they are in multiplication, two numbers having the same base are in multiplication, we can write them as m plus n. Right? This is the product rule. Now if we have the same base but they are in division, the powers will get subtracted. If we have a to the power m whole power as n, this can be written as a to the power mn. If we have a to the power m and b to the power m, we can write it as a multiplied by b whole power as m. If we have a to the power minus 1, that is 1 upon a. If we have a to the power 0, anything raised to the power 0 will always give us the answer as 1. So these are some of the basic laws that we have already done and we are familiar with them, right? So we are going to use these in our questions. Okay. Moving ahead, just to see, we have in the first part minus 2 to the power minus 3, we have to simplify and then write in the exponential form, and minus 2 to the power minus 4. So what is same here? The base is same. In both the numbers, the base is -2. So -2 and powers will get added. -3 plus -4. We get -2 to the power -3 plus minus is -4. So -2 to the power -7. -3 and -4 forms -7. So we have simplified and written the answer in exponential form only. Okay, in the second part, we have p to the power 3 into p to the power -10. Again we see the bases are same. The powers will get added. So p to the power 3 plus -10, we get p to the power 3 minus 10, and that will give you p to the power how much? 7 of negative, because 10 is greater here. In the third part of the question, we have 3 to the power 2, 3 to the power -5, 3 to the power 6. We have the same basis. So powers are going to get added. 2 plus -5 plus 6. We get 3 to the power 2 minus 5 plus 6. So 3 to the power 2 and 6 is 8 minus 5. 3 to the power 8 minus 5 is 3. So this would be the answer. These are the exponential form, the simplified exponential form. Clear? Moving ahead. So we have to solve these questions. The first question is, we have to find the value of 2 to the power -3. 2 to the power -3 can be written whenever you will have negative powers, you will first make them positive. So we know that a to the power -m is 1 upon a to the power m. So 2 to the power -3 is 1 upon 2 to the power 3. 2 to the power 3 means 2 multiplied with 3 times. 1 upon 8 is the answer for it. In the second part, we have 1 upon 3 to the power -2. First of all, making the power positive, we will take this in numerator. Take the reciprocal of it, the power becomes positive. And 3 square is 9. Okay. Moving ahead, another question. We have to just simplify them. Okay, so to simplify them, just see, we have the same basis here. So -4 to the power 5 plus -10. When we have the same numbers in product, that means the numbers having the same base in product, we will add the powers. We get -4 to the power 5 plus minus is -10. Right? -4 to the power 5 minus 10 is -5. Clear? So now it will be in terms of positive exponential form. We will write 1 upon -4 to the power 5. In the second part, if you observe carefully, we have the same base again, but with the division sign. So whenever we have that, what do? We subtract the powers. So also whenever you use the property, you just write it as a to the power m and a to the power n is equal to a to the power m plus n. Just give the reason. Here also, if we will be using, we will write it as 2 to the power 5 minus 6. So we will write, if we have a to the power m in division with a to the power n, then what do we do with that? We subtract the powers, right? So let us subtract the powers. So we will get a to the power m minus n. Okay, 2 to the power minus will be plus, 5 plus 6. And 2 to the power, what we will get? 11. It's with positive exponential, right? The positive power it has, so it's done now. Next part, we have to express 4 to the power -3 as a power with the base 2. Okay, so 4 to the power -3 we have. Now we have to make this as 2. 4 can be written as 2 to the power 2 and its power is -3. Now we know that if we have a to the power m, whose power is n, we write it as a to the power mn. So here also a to the power, that means a is what here? 2. So we will write 2 to the power, what we will write? 2 into -3, that is 2 to the power, just see, -6. So we have expressed this as a power with base 2. Right? So base is now 2 instead of 4. Okay. The next part, here we have to simplify and write the answer in exponential form. So just see here. First part, what we have? 2 to the power 5 into 2 to the power 8 whole power. Okay, we have a division sign actually. So I'll just change it. 2 to the power 5 in division with 2 to the power 8 whole power as 5 multiplied with 2 to the power minus 5. Okay. So, first of all, you are going to solve the bracket according to BODMAS rule. Now, we have the same base with the division sign. So, we will subtract the powers. 5 minus 8 whole power is 5 multiplied with 2 to the power minus 5. Now, what we will get? 5 minus 8 is minus 3 whole power is 5 multiplied with 2 to the power minus 5. So, whenever you are using a property or a law of exponent, you just have to mention that in bracket. Now, here this will get multiplied 2 to the power 3 5s are 15 minus 15 into 2 to the power minus 5. Now we see that we have 2 as the base in both of them but with different powers. So 2 to the power, what we are going to do? We will add the powers minus 15 plus minus 5. Now just see 2 to the power minus 15 plus minus minus 5. So what we get? 2 to the power minus 20. Okay, what we are going to get? 2 to the power minus 20. I hope this is clear. So just see, here in this step, we have used the division rule. So we will write a to the power m. In division with a to the power n is a to the power m minus n. Similarly, here also we have used one property, that is a to the power m whole power as n is written as a to the power mn after multiplication. Then in this also we have used the addition power a to the power n and a to the power m, that is a m plus n. So whenever you solve a question, just beside that step you write the law also that you are using, right? It helps you doing the correct question, as well as you will not be at the risk of losing marks. Okay, moving on to the next question, just to see a second part of it. In the second part, what is given to us? We are given minus 4 to the power minus 3 into 5 to the power minus 3 into minus 5 to the power minus 3, right? Both of them have the same power. Okay, now just see, minus 4 to the power minus 3 into, we have different bases but same powers, and we know that if we have a to the power m and b to the power m, same powers, it can be written as ab to the power m, right? So we can write it as 5 into minus 5 whole power as minus 3. So we will get minus 4 to the power minus 3 into, what we will get here? Minus 25, right? Or we can just write it as, see, 5 into minus 5 minus 25 whole power as minus 3. Now just see here, minus 4 is there, we can write it as minus 1 into 4 whole power as minus 3. Similarly, we can write minus 1 into 25 whole power as minus 3. Okay, also we see that these three have the same power. So instead of collecting 2 at once, you can combine the 3 also. So now if we see, the powers are same here, right? So what we can do, we can write minus 4 into minus 25 whole power is minus 3. We get minus minus will get plus, 25 into 4 is 100 to the power minus 3, that can be written as 1 upon 100 to the power 3. But there is another way to do it with less number of steps. Let's do that. So what we will do, okay, I'll just tell you how to do it. So this we have, okay. So there is another method for doing the second part. Just see, minus 4 to the power minus 3, 5 to the power minus 3 and minus 5 to the power minus 3. We see we have different bases but same powers. So we can just write minus 4 into 5 into minus 5 whole power is minus 3. See, minus and minus would be plus. 5 5s are 25. 25 into 4 is 100. 100 to the power minus 3, which is 1 upon 100 to the power 3. So like this also we can solve it, right? You combine 2 at once or 3 at once. That is your choice. Okay. Now in the next part, what do we have? We have 1 upon 8 into 3 to the power minus 3. How can we write 8 in terms of exponent? We can write it as 2 to the power 3. That is 8 only. Right? 1 upon 2 to the power 3 can be written as 2 to the power minus 3 in the numerator into 3 to the power minus 3. We see we have the same powers, so we can multiply the bases and write the power. So we have 6 to the power minus 3, that is 1 upon 6 to the power 3. So we have expressed the answer in the form of exponential. Okay. Okay, now the last part. In the last part, we have minus 3 to the power 4 and 5 upon 3 to the power 4. Both of them have the same power. So bases can be multiplied like this. Whole power is 4. They will get cancelled. We get minus 5 to the power 4, and this is going to be your answer. Clear? Moving on to the next, just see. We have to find what? We have to find m here, and we have been given minus 3 to the power m plus 1 into minus 3 to the power 5 is equal to minus 3 whole power 7. Are the bases same? Yes, we have the same bases. So students, when we have the same base, what do we do with the powers? We add them. Minus 3 to the power m plus 1 plus 5 equals minus 3 to the power 7. Now both the side bases are same. That means powers can be equated. They both are equal only when the powers are equated. So we have minus 3 to the power m plus 5 plus 1 is 6 equals minus 3 to the power 7. So we can write m plus 6 is equal to 7. M is equal to 7 minus 6. So m is equal to 1. What is the value of m here? 1. Now you just put 1 here. What we will get? Minus 3 to the power 2 into 3 minus 3 to the power 5. So yes, when we solve it, we get minus 3 to the power 7. So we can verify our answer also by putting in the original expression that is given to us. So what is the value of m here? 1. So whenever we have such kind of questions, we have to use the laws, and then we have to make the bases same so that the powers can be compared. Right? Moving to the next question. Here we have 2 upon 3 whole power is minus 2. We have to find its value. So if we take the reciprocal of this, will the power become positive? Yes. So we'll write 3 upon 2 whole power is 2. 3 square upon 2 square. So we have 3 3s are 9. 2 2s are 4. 9 upon 4 is the value of 2 upon 3 to the power minus 2. So whenever you have negative exponent, first make it positive by taking the reciprocal of that number. Okay, and when you find the reciprocal, the power becomes positive. So positive powers, you know how to solve easily. We are already familiar with that. Now here is another question. We have to just simplify it. Okay, so these kind of questions are important and are asked in your examination. So pay attention. We have 1 upon 3 to the power minus 2. First of all, we'll make its power positive. We will write 3 to the power minus 2. Instead of minus 2, it will become plus 2. Reason is we have taken the reciprocal. 3 upon 1 is 3 only. The next is 1 upon 2 to the power minus 3. It will become 2 to the power plus 3. Okay, this is there. Divided by 1 upon 4 to the power minus 2. So it will become 4 to the power 2. We have taken the reciprocal. Now 3 to the power 2 minus 2 to the power 3 in division with 4 to the power 2. So 3 to the power 2 is 9 minus 2 to the power 3 is 8 and division with 4 square is 16. So 9 minus 8 is 1. 1 divided by 16. We have 1 upon 16 as the answer to this question. Clear? So first of all, according to BODMAS, you're going to solve the bracket part first and then the another things. Like division will be done at the end. 1 would be divided with 16.